All right, we're going to go ahead and continue our lecture today that we had in class, especially for second block. We first discussed Lewis dot structures and how to draw those for our molecular molecules. Remember that our molecular molecules are our covalent compounds, our nonmetals that share electrons amongst each other. I know we talked about in class about how to draw and distribute our valence electrons and how to establish bonds between those atoms. And now we need to learn about the different types of molecular shapes that go. For this class, I only want you to know 5 main shapes and how to determine what Lewis structure your shape is going to be in. So what I'm going to do is go over each shape individually and give you an example of one of the molecules that it'll look like for those shapes. All right, so our first shape we're going to do is going to be a linear shape. So linear, that sounds exactly what it means. It's like a straight line. So with linear shapes, it's going to have one bonded atom and 0 lone pairs. So when we're drawing out an example of a linear, a good example of that is one of our diatomic molecules like H2 or hydride. So here we have H2. If I were to draw out the Lewis structure for H2, it would look like this. Because remember, we have 2 molecules. Let me erase that ugly thing I just drew right there. We have 2 hydrogens, both with 1 valence electron. And between them, they have 1 bond. And if you noticed, here the hydrogen has 1 atom sharing with the other electron over here with the other hydrogen. There's 2 bonded atoms. There are absolutely no lone pairs, so this would be linear. Another form of linear and have 2 bonded atoms and no lone pairs. So we have linear can be just 1 bonded atom with no lone pairs or 2 bonded atoms with no lone pairs. So another example of linear could be our CO2, which we did today in class. So CO2, remember that carbon is our central atom. We draw our skeletal with our oxygens on the outside. Once I draw the Lewis structure, it ends up being double bonds, just like we did in class today. But there are no lone pairs on my central atom. Here, carbon is my central atom. There are no lone pairs, and there's 2 bonded atoms. So right here, my central atom, no lone pairs. And I have 1, 2 bonded atoms. So our first molecular shape is linear. It can either be 1 atom bonded with no lone pairs or 2 atoms bonded with no lone pairs. All right, so our next shape that we're going to get into is going to be our bent shape. And our bent shape can also have 2 different types of variations. All right, so bent. Bent can consist of a bonded atom, I have 2 bonded atoms with 1 lone pair, or 2 bonded atoms with 2 lone pair. Remember, when I'm saying lone pair, I mean electrons on the central atom. And when I'm saying bonded, it's the elements bonded to the central atom. All right, so an example, our first example of our bent with the two bonded atom with one lone pair, I'm going to use SiCl2, so silicon dichloride. So here, Si is going to be our central atom. And then coming off of that, we're going to have two chlorines. Silicon is in group 14, meaning it only has 4 valence electrons. And then you have chloride, which is in group 17, so he has 7. So when I draw out the Lewis structure, it's going to be something like this. 2, 3, 4, 5, 6. And then you're going to have this lone pair right here above silicon. So you have two bonded atoms, one lone pair, and this would be bent. This lone pair right here is pushing down your two chlorides, causing it to have a bent shape. Another example of this would be H2O, or water. So water is just a little bit different. Water has two bonded atoms with two lone pairs. It still gives the same bent shape. Remember in class when we drew our water out? So here's water, has two bonded atoms, but it has 1, 2, 1, 2. It has two lone pairs shown here. Kind of looks like my little mouse ears. So one bonded atom here, another bonded atom, and on my central atom, I have two lone pairs. This is also a bent shape. All right, so we've gone through two shapes so far. We went through our bent shape. So I'm messing all my stuff up over here. Go off there. Get off this. And then we did our linear shape. Doing that. Sitting here trying to move all my Post-its around. Okay, now that I've got all the little bugs fixed here. So we've gone over linear shape, we went over bent, and now we need to go over our trigonal planar. So let's add another sticky note. Okay, so we'll go over trigonal planar. Trigonal planar is pretty easy because there's only one variation of the shape. So with trigonal planar, you have three bonded atoms with no lone pairs. So bonded, you have 3, lone pair, you have 0. So an example of a trigonal planar would be like boron trichloride, so BCl3. So boron would go in the middle. We get our chlorides all lined up here. Now, the way I'm drawing my Lewis structures are pretty finished. I'm not going through the steps on how to draw them. That's what you all should be doing in your first few steps of your practice tomorrow or today, whenever you're listening to this screencast. So I'm kind of showing you the finished product. So here we have boron. Boron's one of our exceptions. He doesn't have to have a full octet. He usually just likes to have 6 altogether. But anyways, here we have boron trichloride. He has 3 chlorine atoms bonded to him. He has no lone pairs on his central atom. So his shape would be trigonal planar.